Hi everyone, today I'd like to go over Caesar Cipher with you and give you an introduction to it. We will go over a straightforward example and then I will show you how this process can be done in Python. So what is Caesar Cipher? Caesar Cipher is one of the oldest and simplest crypto systems. It was used by Caesar, the famous Roman emperor, more than 2000 years ago. He used this method to communicate privately and securely. Caesar Cipher is also known as Shift Cipher. Caesar Cipher relies on modular arithmetic. So going forward, I assume you know about modular arithmetic. However, as I will go through the example and I explain it, I hope it becomes more clear. If you would like to know more about modular arithmetic, please let me know in this comment section and I will create more content about it. Lastly, an important note, and I think most of you know this by now, that Caesar Cipher is completely obsolete and no longer in use. It only has historical importance at this point, and it is only being used for teaching purposes in cryptography and as a toy example. So to work with Caesar Cipher, it is important to understand the mapping between letters of a language and numbers. Note in my example, I'm going to use English language, but if you're using another language, the mapping must be modified. We map English letters to a number in mod 26. So A is mapped to 0, B is mapped to 1, and so on until Z is mapped to 25. You might wonder why we don't map A to number 1, for example. There's nothing wrong with that, but if you go ahead with A being 1, then B must be 2, and so on and so forth. In that sense, Z would be mapped to 26, which modulo 26 is actually equal to 0, which means that Z is being mapped to 0, and that is not preferable. Essentially, there's nothing wrong with mapping A to 1 or any other format as long as you're being consistent and apply the same mapping as you go, but it makes it a lot easier to understand the mapping if you start mapping A to 0. So going forward, we're going to be using this mapping, which is pretty much the standard in cryptography to encrypt and decrypt our messages. So here I'm gonna go over a quick example. So first we're gonna show how the encryption is gonna work. So the example that I chose is the word hello world. So one thing you notice is that for encrypting a message, we don't care about uppercase letters or lowercase letters. We actually prefer to keep it consistent. So if you want to use uppercase letters, that's fine, but just use uppercase throughout or like lowercase throughout. So we transform and we also get rid of white spaces because those things, if you include white space in your encrypted message, then it makes it easier to break the system. So in general, we get rid of white spaces and we use uh, either uppercase throughout or lowercase throughout. So we transform hello world, removing the white spaces, transforming the uppercase to lowercase letters, and we have the hello world in the in the list. And then we use that mapping that I showed before in the previous slide. So letter H is 7 in modulo 26. E is 4 modulo 26, and so on and so forth, and we do it for the rest of the letters. So we have this mapping, and we store these values in this list. And for the key that we're going to be using in this example, we're going to use the letter J, because this is just an example, and we just use the letter J as an example to see how it works. So how is this gonna work is that we add the letter J to the word hello word modulo 26 and we get a new set of letters. So how does this process gonna work is we add number 9 to the whole word hello world. So the first letter, for instance, is 7, so we add number 9 to 7, we add 9 to 4, and we add this 9 to all the elements in the previous list. So for example, 7 plus 9 is 16, 4 plus 9 is 13, 11 plus 9, 20, and we get this new list. Now notice we have this number 31 in the middle of the list. So that number 31 is greater than 26. It doesn't really correspond to any letter in the mapping that we used in the previous slide. So here where we use modular arithmetic, we know the number 31, when it's being divided by 26, you get a remainder of 5. So we can see the numbers that are below 26, we keep them the same. And if the number is greater than 26, we just find its remainder when we are dividing by 26. And we get this new list. And now we can, again, use the same mapping and transform these numbers to a set of English letters. So number 16, for example, corresponds to Q, 13 corresponds to N, and so on and so forth. Now notice we have 3 U's in the encrypted message. These U's correspond to letter L. So you can already see that it may not be the hardest thing in the world to decrypt this message, as we will later see how we can do the decryption and inverse this process. But you can imagine if I give you a random string and I tell you it was encrypted by the Caesar method, you can use this kind of approach and analysis to find what the key was used by frequency, letter analysis, and things like that. So in the next slide, we're going to see how we can decrypt this message. So we showed in the previous slide that the word hello world, when it's added to the key J, you get this string, QNUUXFXAUM, which correspond to the corresponding list that you see in front of it. So in order to decrypt this message and make something meaningful from it, we need to inverse the same process. So instead of adding the letter J to this new string that we got, this time we subtract letter J, or its corresponding value in mod 26, which is 9. So last time we added letter J. Now this time we subtract letter J from the numbers in this list. So for example, we subtract J from letter Q or their corresponding values in the mapping. So it would be 16 minus 9. Same thing with N. So N minus J corresponds to 13 minus 9, and so on and so forth. Now, if you notice in the middle again, somewhere in the middle, we have 5 minus 9. So 5 minus 9 is actually a negative number, which corresponds to negative 4. And then again, here, it's not a number between 0 to 25, but we can transform it to a number between 0 to 25 by doing the modular arithmetic. Actually, negative 4 corresponds to number 22. So number 22 and negative 4 are actually the same thing in modular, in mod 26, using modular arithmetic. So we see we get this list of numbers 7, 4, 11, 11, and so on and so forth. And Once again, we use the same mapping to find which letter they correspond to. And it turns out number 7 corresponds to letter H, number 4 corresponds to letter E, and if you do this process, you see you're gonna get hello world back. And there you have it. We have decrypted the word hello world. This was what we started with. We encrypted it. We got the string QNUUXFXAUM using the key J. We use the same key to decrypt the message, and we got the word hello world back once again. Now that we have gone through this example encrypting a word using cipher method, we decrypt the same example using the cipher method. Now it's time to go through this example in Python and see how we can code things of this nature.